Hi guys, good morning. Today we're going to take notes over turgor pressure and tropisms. Our PowerPoint for right now is talking only about turgor pressure. And what is turgor pressure? Well, let's look at these two plants. One of them is alive and straight up, and the other one is leaning over and pretty much dead, right? The big science word for a plant leaning over is wilting. What keeps a plant standing up and alive, and what keeps the plant rigid like that, is high turgor pressure in the cells. Okay? This is caused by changes in turgor pressure. If it has low turgor pressure, if the water leaves the cells so that the cells can't sustain themselves, then they're going to die. They're going to collapse and the plant's going to wilt. So the textbook definition for turgor pressure that you're going to write down here is that turgor pressure is the outward force in a plant cell when the vacuoles fill up with water. And which causes the cell membrane to push up against the cell wall. Now that is a lot to fit, and I didn't fit it all. It goes off the page. Just put it down in your own words if you want to as well. So let's read it again one more time. It's the outward force in a plant cell when the vacuoles fill up with water, causing the cell membrane to push against the cell wall. So essentially, the vacuole inside the plant cell, why it's so big, like we talked about before, is that it needs to contain a lot of water. And once there's a lot of water in there, there's a force that's created from that vacuole, from all that water, and it pushes out from the vacuole onto the cell membrane. And that cell membrane pushes up against the cell wall, and it causes the rest of the cell to be rigid. It's supposed to have a shape, right? What causes that plant cell to have a shape is turgor pressure from the vacuole. So this plant has high turgor pressure. So low turgor pressure would be a plant wilting. And why is turgor pressure important to plants? Like I said, it gives them the rigidness to stand straight up. And without normal turgor pressure, plants begin to wilt. So let's do this real quick. Turgor pressure is, we already have that, the stimulus. So the stimulus is an action or situation that causes a response, right? So for us, the stimulus is the vacuole filling up with water. And the response is plant cell becoming rigid. From the water pressure, or the pressure created by the water. And if we go down here, we have a turgid cell and a flaccid cell. So these things aren't exactly on the PowerPoint. I'm just going to go over it real quick. Turgid cell is going to be a cell that has turgor pressure. Remember, only plant cells have turgor pressure or high turgor pressure because they have a large vacuole that can contain a lot of water. A flaccid cell, I'm just going to put low turgor pressure. And now you need to draw a turgid cell, and then draw a flaccid cell. So a turgid cell would just be a regular plant cell. My regular plant cell does not look great, but I just want to emphasize that there's a cell wall that has a cell membrane right behind it. High turgor pressure means that the plant cell is in full bloom, right? It's able to keep that stiff, rigid shape. And what you need to emphasize for a cell that has high turgor pressure is that vacuole, that one large vacuole in a plant cell, is filled up with water. And that water is giving out force or pressure to the rest of the cell, keeping its shape. All right, now I'm going to draw a plant cell that has low turgor pressure. And this is a plant cell that is collapsing in on itself, that is folding underneath the weight of having a stiff, rigid outer shell, but no water to give it pressure. So when you don't feed your plants or give your plants water, this is what happens to their cells. And with barely any pressure to give any force, the plant cell is collapsing in. And remember, low turgor pressure means wilting, gonna wilt. Okay, so we are done with turgor pressure. Let's go to tropisms. All right, so tropism is let's see, I think there's a textbook definition here. Yeah. Here we go. Let me get red. All right. Tropism is a turning of all or part of an organism in a particular direction in response to external stimulus. You can just put the response of an organism in a particular direction in response to an external stimulus. Actually, to an external stimulus. To an external stimulus. Well, that's a lot. That's a mouthful. So tropism is the response of an organism in a particular direction to an external stimulus. And for this 6 weeks, we're mainly talking about plants. It's how plants adjust to the stimulus of light, what direction they go to when it comes to the stimulus of light, to gravity, to touch, to heat, to water. All right? And they can be positive or negative tropisms. Positive means they go towards the stimulus, and negative means they move away from the stimulus. Positive means moves towards the stimulus. Negative means away, moves away. An example of positive tropism is phototropism. A plant grows towards the sun. An example of negative tropism is the stomata, or the stalk of the plant, basically the rest of the plant that grows outside of the earth, the green portion you see. It's a negative tropism when it's reacting to geotropism. So that stalk from the plant grows up while gravity pulls you down. So it's going away from the source. Remember, a stimulus is let's put the textbook definition here. A detectable change in the internal or external environment of an organism. Okay, let's move on to phototropism. So photo means light. You should probably think that photo means photosynthesis, means getting energy from sun, right? Getting food from sun in the plant. And so would a plant want to move away from or towards the sun to get more photosynthesis? It would want to do a positive response, right? So the stimulus would be the sun. And the response of the plant bends or grows towards so the type of response would be positive. And a picture to show that? Well, let's see. Let's make a beautiful picture. Beautiful sun, beautiful sun. Okay, say that's the window. And say the plant. And say sunlight only goes in through there. Let's make it a little teapot. The plant maybe not this extreme. Could be this extreme, actually. There are examples of that. Is going to bend towards the source of light so that it can grow. Bend its body every which way. I mean, this is probably a little bit much, but you get the idea, right? All right, so that's an example of phototropism. And then right here, it says seedlings sprout due to the water pressure in the cell. I want you to realize that seeds sprouting happens because of high turgor pressure, because there's water inside that seed pushing outwards. Okay? And because it's pushing outwards, eventually the shell is going to crack and the rest of the plant is going to come out. All right, let's go to gravitropism. Or, as I've said it before, geotropism. Same thing. All right, geotropism. Organisms respond